In the last video, we discussed about maxima minima, correct? And different types of how to calculate maxima minima and all. In the sense, the second derivative test, first derivative and everything. Now, let's apply those concepts and let's solve few problems based on it. Yeah. Look at the first one here. Find the maximum and minimum values, if any, which is a very, very important word because sometimes maximum and minimum can not even exist. That's why. Of the following functions given by so much and so much. Yeah. So let's do the first one. F of x is equal to 2x minus 1 whole square plus 3. Now let's go step by step by step. Yeah. So we'll start by taking 2x minus 1 whole square. See, this is always greater than or equal to 0. Makes sense? So add 3 on both the sides. That means 2x minus 1 whole square plus 3 is greater than or equal to 3. That's basically 0 plus 3. Yeah. So the minimum value is going to be 3. Maximum value does not exist. Because what do you say? Infinity is the maximum value. I mean, it makes no sense, correct? So maximum value does not exist. That's all. Very simple. Fine. So you make sure that you have within that particular range. Then go ahead and solve it. That's all. Easy. Very, very easy. Let's do the second one, which is very, very similar to this one. Yeah. Let's do the next one. See the second one. See, you have f of x minus of x minus 1 whole square plus 10, right? Now, x minus 1 whole square is always greater than or equal to 0. Yeah. So, minus of x minus 1 whole square is always less than or equal to 0. Correct. Add 10 on both the sides. So, minus of x minus 1 whole square plus 10 is always less than or equal to 10. Always less than or equal to 10. Correct. So, the minimum value and maximum value. Maximum value is going to be 10. It can't go beyond 10, right? Minimum value does not exist. The reason why we write does not exist because minimum value can go till infinity. Correct? So that's why we say that minimum value does not exist. Maximum value is 10. That's it. Okay. Let's do the second question now. All right. Again, it's the same logic. Sin 2x plus 5. Correct. So when you have sine of 2x, you know sine 2x is between minus 1 and 1. So we can write this as sine 2x is between 1 and minus 1. Correct? Add 5 to all the three sides. That means minus 1 plus 5 less than or equal to sine of 2x plus 5 less than or equal to 1 plus 5. Correct? So 4 less than or equal to sine of 2x plus 5 less than or equal to 6. So the maximum value for this function, maximum value is 6 and minimum value is 4 because it can't go less than 4 or it cannot go more than 6. So the range is from 4 to 6. That's all. Very, very simple. Let's do the next one, the h of x, next part. All right. See, for the second part, you know that x value is between minus 1 to 1, right? Because it's an open bracket, right? It's an open interval. It's not a closed interval. So x is from minus 1 to 1. Add 1 on all the sides because it says x plus 1, right? So minus 1 plus 1 less than x plus 1 less than 1 plus 1. So 0 less than x plus 1 less than 2, right? Now here you can say that it is between 0 to 2, right? It is between 0 to 2. So any value between 0 to 2, but 0 and 2 are not included here. Correct? Since 0 and 2 are not included, whatever value you are going to take, that means any value from 1 to 1 if you're sorry 1 to minus 1 if you're taking, you're going to get a value from 0 to 2. So we can say that 0 less than x plus 1 less than 2, or x plus 1 has a range. So the values, what you can say, this belongs to 0 comma 2. But do you have a maximum value? Can you say it's equal to 2? Nope, because it's a strict inequality. It's not a slack inequality, right? So if someone says 1.9, another person will come and say 1.99. Next person will say 1.9999. So do you have one particular number to tell that it is the maximum value? No, right? So what we can say, maximum value and the minimum value do not exist. They do not exist. Understood? So this is what we call as, or this is how you calculate the maximum minimum. All right. Now let's solve the next question. See the third question. Here you have, find the local maxima and local minima, if any, of the following functions, and then find also the local maximum and local minimum values as the case may be. Alright, now here we have to take the first derivative as well as the second derivative part. Both we need to consider. Alright, so first let's take the first one, sin x plus cos x. And also you need to understand that x value is in the first quadrant 0 to pi by 2. Right? Differentiate. So you have h dash of x is equal to cos x minus sin x, correct? Cos x minus sin x. Equate it to 0. Remember the points of inflection and all we have to calculate. Equate it to 0. When you equate it, you'll get cos x is equal to sin x. Or tan x is equal to 1. See, tan x is equal to 1, that too in the first quadrant. That means theta value has to be equal to, or x value has to be pi by 4. That's 45 degree. Right? So x is equal to pi by 4. So we got the point of inflection for this particular function. Now what you do double derivative. Okay, so to show that whether this is the point of maxima or the point of minima. Yeah. F double dash of x is equal to minus sin x minus cos x. Put x as pi by 4. You'll get it as minus 1 by root 2 minus 1 by root 2 minus 2 by root 2, which is minus root 2. Now it is negative, right? So if the second derivative is negative, what do you conclude from that? That it is going to be a maximum value, correct? So it's going to be maxima in this case. To figure out the maximum value, what do? You take this pi by 4, substitute in this h of x function, correct? So if you substitute here, you'll get sin pi by 4, 1 by root 2 plus 1 by root 2, 2 by root 2, which is root 2. So root 2 is the maximum value, and the point what we have, the point of inflection, is the local maxima. Understood what to go about, how to go about this? So remember, let me just repeat that step one more time. Differentiate. Equate it to 0. Get the point of inflection. Alright. Once you get the point of inflection, then do the double derivative, second derivative test. Once you do the double derivative, substitute the value, that point of inflection, then you will understand whether it's a point of local maxima or local minima. Correct? Once you have that value of local maxima or minima, substitute that back in the function, you will get the value of maximum or value of minimum. Understood? Let's do the second one, which is very similar to the first one if you look at it. See the second one. First, f of x, sorry, f dash of x, cos x plus sin x. Yeah? Equate it to 0, f dash of x. So you're going to get minus tan x, because take the sin x to the other side. So you'll get minus tan x is equal to 1, tan x is equal to minus 1. Now this can happen in two quadrants, that is the second quadrant or the fourth quadrant, correct? Tan is negative in both the quadrants. That means x value is either, first one will do it for the second quadrant. Yeah, so if you're doing for the second quadrant, it's gonna be pi minus pi by 4, which is 3 pi by 4, or x is 2 pi minus pi by 4, which is equal to 7 pi by 4. Yeah, so we have two values. One is 3 pi by 4, one is 7 pi by 4, correct? So we have these two. We need to check for both because there are 2 points of inflections here, isn't it? Now first, let's do the second derivative test, or you can say the double derivative test. Okay, so when you're doing double f double dash of x, f double dash of x, you'll get minus sin x plus cos x, correct? First, we'll put the value of 3 pi by 4, the first point of inflection. So when you have that, you'll get minus sine of 3 pi by 4, which is going to be 1 by root 2. The reason why we have plus 1 by root 2 is sine is positive in the second quadrant. That's why. Okay. Then plus cos of 3 pi by 4, which is going to be minus 1 by root 2, because cos is negative. So what do you get? Minus 1 by root 2, minus 1 by root 2, which is basically minus root 2, because you'll get minus 2 by root 2, right? That means f double dash of x is negative. Since this is less than 0, this point is going to be a maximum, correct? Now we are going to apply 7 pi by 4. Let's do it here itself. We'll apply 7 pi by 4 and check here. So what we have, now is minus of sine of 7 pi by 4 is minus 1 by root 2, minus 1 by root 2, plus cos is positive in the fourth quadrant, right? So this is going to be just 1 by root 2. So you are going to get plus 1 by root 2 plus 1 by root 2, which is plus root 2, greater than 0. So minimum. So here you can write this as this is going to be a minimum. Yeah. Now what we'll do, so we'll substitute this back in the equation, that f of x, to find the values. Right. So if you take 3 pi by 4, so sine 3 pi by 4 is 1 by root 2 minus of minus plus 1 by root 2. So root 2 is the maximum value, not local maxima, but maximum value. The next one, minimum, is going to be minus 1 by root 2 minus 1 by root 2 minus root 2. This is for 7 pi by 4, correct? So we got the maximum value, minimum value. Let's do the third one, which is very similar to this one. All right. See the third one. So you have g of x or g dash of x. Directly I'll do it. 1 by 2 minus 2 divided by x square, equated to 0. So you will get half is equal to 2 by x square, or x square is equal to 4 after you cross multiply. So you get x as plus or minus 2. You have 2 points of inflection, just like whatever we did in the previous case. But the condition says otherwise. The condition what you have is x is greater than 0. So discard negative 2, keep only positive 2. Okay. So f double dash of x, second derivative test. This is going to become 2 into 3 divided by x cube. The minus minus gets cancelled out anyway. 6 divided by x cube, correct? Since you have 6 by x cube, so what you're going to do here, sorry, this is going to be 2, not 6, sorry. This is going to be 4. 4 by x cube. Now what you'll do, substitute x as 2. So you'll get it as 4 by 2 cube. Guys, this is greater than 0. I don't want the value of this, right? It's greater than 0. That's all it's required from. Once you know it's greater than 0, then what do? You substitute back here. You'll get the minimum. Correct? So that means here, g of 2 is equal to 2 by 2 is 1 plus 1. So 2 is the value, but this is the minimum value, not the maximum. Understood? So these are the answers for these 3 questions. All right, now let's do the next one. See the fourth one. Find the absolute maximum and absolute minimum. See, absolute maximum and minimum, we take the 2 endpoints and even the point of inflection, and we figure out which is the maximum, which is the minimum. Yeah. Find the absolute maximum and for this one. So the first one will take f dash of x becomes cos x minus sin x. Fine, equate it to 0. So you'll get tan x is equal to 1, x is equal to pi by 4. Because tan is positive only in the first quadrant, as in first and the third, but we are taking this one. Now, you got the point of inflection to be pi by 4. Yeah. Substitute these 3 values here. That means, what are the 2 endpoints given in the question? 0 and pi. And the point of inflection is what? Pi by 4. So we'll substitute all the 3 and we'll check which is the greater one, which is the lesser one. So put f of 0. F of 0 becomes 0 plus 1, which is 1. Yeah. Now we'll do f of pi by 4. So this is going to be 1 by root 2 plus 1 by root 2. 1 by root 2 plus 1 by root 2 is 2 by root 2, which is just root 2. Correct. And f of pi. So this is going to become 0 minus 1, which is minus 1. So the absolute maximum is going to be root of 2 and absolute minimum is going to be at, or absolute minimum value is minus 1, maximum is root 2. Understood? So this is how you solve. Now let's do the next one. All right. See the second one. For the second one, f dash of x is equal to 4 minus half into 2x or 4 minus x equated to 0. So you will get x value as 4. Isn't it? Now this is the point of inflection. Now what we are going to do, we have to calculate at 3 different points. At minus 2, 4, 9 by 2. Correct? So now what do we have? F of minus 2. 4 times minus 2 is minus 8. Minus half into minus 2 whole square is 4. Minus 10. We got minus 10. Right? Now the next one is f of 4. Because x value is 4. Point of inflection. 4 into 4, 16. Minus half of 4 square, which is 16. 16 minus 8 is 8. Correct. Now we'll do the same thing for 9 by 2. That is f of 9 by 2. 4 into 9 by 2, which is nothing but 2 into 4. Sorry, 2 into 9. 2 into 9 is 18 minus half of 81 divided by 4. So 18 minus 81 by 4. Correct. So the value of this one is going to be minus 9 by 4. So what you are going to have now is that this is going to be the minimum. This is going to be the maximum. So absolute maximum, absolute minimum. Fair enough? Let's do the fifth one now. See the fifth one. You have find the maximum profit that a company can make if the profit function is given by this. Maximum value they're asking, correct? So first is you differentiate. P dash of x is equal to minus 72 minus 36x. Correct? Substitute this value. So what you're going to do, as substitute in the sense equate it to 0. Sorry, that's what I meant. Now when you equate this to 0, you will get minus 36 is equal to 72. So x is minus 2. Right? So when x is minus 2, then you do p double dash of x. It is maximum, yes, but just to cross check. Alright? So you're going to have minus 36. Directly it's less than 0. So no point in substituting the value of x anyway. So since you know at x equal to minus 2, you're going to have maximum value. Substitute that back in the question, the equation. So you have p of minus 2, 41 plus 72 into 2 minus 18 into 4. Correct? So you are going to get this as 41 plus 144 minus 18 times 4. Correct? Which is 72. So you get 41 plus 72. So final answer is going to be 113. Okay? So final answer is 113. Now, these are one set of problems what we have. So in the next video, we are going to continue, as in it's not that we are going to stop at 5. We are going to continue, but we'll continue in the next video.